All right, why don't we go ahead and get started? So, for those of you that don't know me, my name is Dave Eckroat. I'm the director of IDEA StatiCa US, and we're happy to have you attend the webinar. Today, we're going to be talking about something a little bit different than probably all of our previous webinars, in that we're talking about concrete, and specifically our detail application. So, I'm going to be running through a couple of examples for you. Just as usual, I'm sure everybody's used GoToWebinar 100 million times at this point. But if you have any questions, just feel free to drop them in the question box right there on the main panel of the GoToWebinar screen. So now if we just look at an agenda for the webinar today, one, we're going to just kind of introduce detail. I'm not sure how many of you already know detail or are using it. So we're going to kind of get into, kind of explain what that is. Then I'm going to hand off and hand it to Andrea, who will then run through two problems. One will be a transfer beam, and then also looking at a walking column, similar to what you see on the screen there in the picture, that we found through Structure Magazine. And then we're going to talk a little bit more about how to kind of learn about detail, learn more about how to use the program. And we're going to change things up a little bit this week, in that we're going to kind of stop it a couple of times in the session and kind of answer some questions there. Obviously, we can do a Q&A at the end as well, but just to try to kind of keep things moving a little bit. So first thing I wanted to do before we get into the discussion is just we have a couple of poll questions for you. So I'm going to launch this first poll question. And really, it's just talking about, okay, how many projects, what percentage of your projects really are using structural concrete, excluding foundations? I mean, obviously, every project has foundations and particularly, sometimes concrete. So we'll give that a minute to let everybody answer. Okay, we're going to go ahead and close that poll. And now let me share just kind of what the results were. So the biggest percentage is actually 0 to 20%. But we have a lot of people that, more than 60, 43% are doing concrete on more than 60% of their projects. So that's good to know. You guys are in the right place, and we have the right audience. So when we talk about IDEA in general, we're a software company that's really focused on structural details. So on the steel side, we're looking at steel connections, and on the concrete side, we're really looking at the discontinuous regions in members, in walls. This graphic kind of gives you some idea as far as what B and D regions are in different members. My personal opinion is the B regions are kind of boring, just kind of simple, more basic type design. The D regions, where you're transitioning between supports or supporting members, cross-section changes, maybe some concentrated loadings or openings. These are the kinds of things that detail is really meant to design. And obviously using, since we are IDEA StatiCa, using finite element analysis to kind of help in that design. And recently, over the last year or so, we have been improving detail to include the ACI codes. So that kind of makes it more useful for those of us here in the US. So go ahead, next slide. So again, just kind of looking at what types of issues IDEA can be used for. So like dapped ends, openings, hangers, walls with openings, frame joints, corbels, brackets, bridge diaphragms. So these are kind of the use cases that we see for detail as being useful. And again, there are situations that, there may not be other software out there that's kind of meant to do these types of designs. So again, trying to fill a niche that I know we've heard from different users. When we start to look at the design and code checking of it, obviously we do an overall check. We look at the strength of both concrete and reinforcement, kind of strength ratios, the anchorage of the bars, stress strain checks within the different members, crack width determination, as well as deflection. So at this point, I just wanted to do one more poll before we get started here, and just kind of understand, how many people did you know that we even had concrete design software? Or do you really only think of IDEA for steel design? So we'll let that poll run so we'll just give it another 10, 15 seconds here. Okay, I guess the good news for us is that overwhelmingly you guys knew that we had concrete software. So that's awesome. That's great to know. So with that, I'm going to hand it off to Andrea, and she will run through a live demo.
All right, thank you, David. All right, so let's jump into this example that I have. It seems simple, but if you find this type of problem, normally what you will do is using a StratAnti methodology. So I'm going to show you how you will start this model from scratch in IDEA Detail. All right, and these are the details that I am going to use. And well, a very brief introduction of this type of problems. Well, in buildings where columns are not continuous along their height, the loads are often transferred via transfer beams or deep beams, as you can see it here. All right. So as a result, these beams can be subject to larger shear forces and bending moments in comparison to conventional beams. So again, how will you address this type of problem? Well, there are guides, and from the ACI code, you will use StratAnti. So let me show you how you can use IDEA StatiCa Detail for this type of situations. So here is IDEA StatiCa Detail. So I'll start in the new project icon over here. We have also imperial units, so make sure you have the correct units over here. So this is the new project wizard. You need to make sure you have the material properties correct over here. And then I'll start with the beams templates, right? And after that, you will need to select a topology. Even though you can modify this topology inside the software, so I'll start with end support here. And then the first screen will be the geometry where you modify everything for this beam. So the first thing to modify is the cross section. So if you change the view to real 3D view, you can see that automatically T shape was selected, all right? But you can modify this over here with this button. Then these are the shapes we can use, all right? And I'll use a rectangular shape here. The height is 60 inches, then we have 20 inches over here, and then I just click OK, and that is automatically changed. Then let's modify the length. So I can put the inches, and then the software automatically will convert that into feet inches if you need that, all right? That's because I set up the units like that, all right? In this case, this beam is trimmed at the end, okay? So you can modify this to known, so that will be an ended beam, all right? Then once you change that, you can see we have here some warnings like you don't have another support, or this is not statically determinate. So you will need to verify. I mean, the software helps you to review those warnings or those modeling things, all right? So in this case, we already have a point support. So you can see the supports list here. So this is the point support. And basically how we model this point support is using a bearing plate, okay? So this helps us to transfer let's say the stresses correctly. And I'll use this point support like to model the column that it's coming in here. So that is how I am going to model. So the width will be the same as the column width that was 16 inches. So I'll modify that. I can place the thickness of that bearing plate that we are using just to transfer the forces. It won't be analyzed or something like that. Let me just put it here and turn off the real 3D so we can see it here in 2D. Okay, so you can see the support over here, and here are the the displacements that you're restricting. Okay, so you can in this case I'll restrict X and C. Okay, and move this position of the plate so we have it just at the edge of this beam. Okay, then I'll copy this point support to the other side. So instead of being from the beginning, I'll select from the end. So now we have this over here, okay? And I'll free the lateral displacement. So we have here the first point support is X and C, and the second will be just C boundary condition activated here. All right. Now, I'll do the same with the top column. So I'll use a transfer device to transfer that point load that I am that will come from this problem. All right. So this is the dead load that will come from the column C, okay? And this is transferred via point load. So again, I am going to use a transfer device. So let me show you how to add that. So once you're here, you just click over the plus icon, then that's how you start adding new entities into this model. So it can be like an opening. You can add more type of supports over here. We have different types of supports. And then these are the load transfer devices. So the one that I'm going to use is bearing plate here, okay? And that will follow the same size of the column at the top, right? That was 20 inches. And then I'll keep the one inch thickness. And then the position that will be at half of this beam, so that will be 7.4. Okay, so now you can see the plate over here. Okay, now let's jump into the loads. Okay, so all these load cases and combinations came with the template. Okay, so you can see the dead load and live load over here, the load cases, and then combinations. So we have the strength combinations and the serviceability combinations. So if you click on those combinations, you can see the factors that we are using. So that is 1.40 multiplied by LC1. LC1 is my dead load. And then we have the same for C combination number 2, the strength combination. You can edit this from here or add more load combinations and select the limit state that you want for these combinations. Then we have the serviceability combinations. That's unity factor for dead and live load, and you need to specify that service load combination to check crack width, deflection, or both. Okay, from this drop-down menu. So in this case, if I go to dead load, you can see we have a line load. I just want to have a point load. So if I click on load impulses, I can see this line load over here. I'll delete this. Okay, so I'm going to add a new load. So these are the type of loads that you can add into a beam element or beam template. So I'll use the point load, and that will be that's the dead load 180 minus 180. Okay. And that is a point load applied into BP1. That's the transmitting device I added at the start. Okay. Now let's change this to load case number 2, that it's the live load. And I'll delete the line load here, create a new point load, and that will be minus 250. Okay. If you have a problem where you have for instance, 2 columns, then you will need to add another transfer device, and then you can select it from this transmitting device option. Okay, so again, this helps me. I mean, this plate helps me to transfer the force in a better way, rather than a point load into just a node of the shell element in the finite element analysis. Okay, so once we have the loads ready, we can jump into the reinforcement. You can see that I am using these tabs over here. Okay, so that changed the options here. To input or edit it, you click over here, and then you will have this wizard to input reinforcement. Okay, so let me show you what are the options for adding reinforcement. We have group of bars, bent up bar, and group of stirrups for beam elements. Okay, so if you see here, we already have a group of stirrups. You can modify the diameter. Okay, and this is based on the ASTM nomenclature, right? So this is 6/8 bar. Okay. You can modify the material of that reinforcement, and then you can select the number of branches. So this will be a 2-ledge stirrup, okay? And then you set up the distances between them. So you can start from beginning, okay? And let's say you start with 2 inches. And here you can see there is just one stirrup here. So let me just show you the 3D model so it's easier. Okay, so this is just one. Then you can say, okay, I want 20 of them and multiply by 10. So the 10 value is the distance between those 20 stirrups. Okay, so also you can select the type of anchorage that you have. So you can see all the options here. Remember, if you hover the mouse over the options, that will tell you what you're selecting. Okay. All right, now let's jump into the group of bars. So in this case, we have this group of bar. Let me delete this to play around with the group of bars input. So if you see the lateral view, you can see that this group of bars have 6 layers between it, and then the distance between those are 10 inches, okay? So I'll change that to just 1 layer, okay? So we don't have distance between those. And then that will be 9/8 diameter. And I want 4 bars in that layer. So you can see here the layer, and then you can select the anchorage type. I'll use the basic one, but we have others over here, others option. And you can select from where is that setup. So this is from the bottom, and the master, we have M1, that is this beam. M1 is this beam, so you're setting up from the bottom. All right, so then I'll copy this group of bar, okay? And now the second group of bar will be 4 layers, okay? The distance will be 10 inches as well. And then we'll decrease that to 5/8 bar. All right. I'll keep the 4 number of layers. And now you can see this is from the bottom. So I can select from the top. So we have those at the top, all right? But then I change this negative value, so that will come below that top edge, all right? So that's it. Then I'll copy the second, I'm going to copy this group of bar. Oh, I deactivated, now it's there, okay? And that will be the third. Okay, that will be a diameter of 8, well, 1 inch diameter, so that will be 8. The same for, and in this case, I'll select again from the bottom, okay? And I'll use the concrete cover type user value so I can move this up, okay? Change it to positive, so that will be there. And the cover will be 6. And this will be 5. Okay, so now you can see how easy it is to modify group of bars here, and I already set up this. So this is like an initial reinforcement arrangement, right? That's how you start modeling reinforcement. And then you can, with this reinforcement, with this first test, you can do a quick check, okay? So now you go into the check tab, and then you can calculate this detail. All right, so once we are under results, we have different tabs to review. So the first one is this summary result. And also you have like all the checks over here, concrete, reinforcement, and anchorage, its utilization, everything, it seems okay. We are on the limit, right? So that is how you start like designing the reinforcement, like testing some arrangements and verifying that you have, that your spacing is okay, all right? Now, you can see the stress flow in this first overview, okay? So this you can see that how this follows the strut anti, stress, like flow. And then you can also, in the summary review, see the reactions and loads on on this on the supports. All right. So that is useful. I mean, this is a very simple model, but that is useful when you have a very funky model, and then you can see those reactions. Then the next thing to review is this concrete strength. All right. So what we are reviewing over here are the stresses versus the limit stress of the concrete. All right. So this is like the unity ratio or the material unity ratio, and then you can change this to the real stresses on this concrete. So you can see that this is almost on the limit because we were using, let me see what we were using here. Let me go back to geometry and see the material that we were using. Give me one sec. So I think it's over here. Yeah, for KCI. So what we are reviewing on the check here is the stresses, and here we are comparing the stresses versus the limit stress of that concrete that we are using. All right. Then this is a concrete check, and then you can jump into reinforcement check. Also, we are reviewing the strain and stress, and you will get the different ratios results over here. So this is a stress, this is a strain versus the limit, okay? And these are just the stresses. So you can see KCI over here. All right, and then the other important result to review is the width of the cracks, okay? So you can activate this crack width color plot. All right, so you can review those width over here, and then you can also activate the ratio, okay, versus, I mean, the width versus the width limit. So you can input here the crack width limit, right, by using these arrows or just placing the value over there. So that will check that for you. And finally, the other important thing to review is the deflection, okay? So you can see the deflection over here, the total deflection, and then this is the deflection caused by variable load, all right? And then you can activate the deform shape, okay? So basically that's the general workflow of IDEA StatiCa detail. David, do we have some questions so far?
We do have a few questions, or just questions that brought up some good information that I didn't present earlier. So one of the questions was just kind of if detail is using solid elements or shell elements. Obviously, at this point, it is just shell elements. So you're just kind of looking at a 2D shell versus kind of a solid brick element. That's something that we're definitely working on. Obviously we're actually working on some verification right now for doing kind of a full 3D solution for these kinds of problems. One thing that I would say is that because we're using shell elements, we are only able to apply in-plane loading at this point. But again, that's going to be changing in the near future. One question, Andrea, that maybe you can help answer. When you put in the plates for the bearing, like the bearing plates, is the software assuming that they're infinitely rigid to transferring the forces to the beam and the support?
Yes, that is correct.
Okay. And then another question was asking whether self-weight, IDEA can calculate the self-weight. I believe you can actually input a separate load impulse, right?
Yeah. If I go into just adding here a load impulse, you can
so there's
input
the
that
self-weight
there. Yeah.
Okay, and let's see. I think there's a couple other questions as far as kind of long-term deflection versus creep effects. Can you talk a little bit about the deflection side of things?
Yeah, if you go into the deflection checks, you will have different, let's say, deflection values. Like you can draw the immediate deflection calculated, caused by total load for that selected combination. Then we have the long-term deflections over here. So that's what you're seeing. I mean, you're seeing here in this case the maximum one, and then the values, the color code graphic over here. So here we have the long term, This is by the variable load, that will be the live load, and then the total one.
Okay.
All right.
Sounds good. So before we jump into the next example, I'm going to fire off another poll question. So this is just kind of how you would handle these types of problems currently. So whether it be, strut and time method, maybe you have some spreadsheets or some other software that you've kind of written some programs in. Maybe you're using detail already. So yeah, we'll just give that a minute, and let me just see if there's any other. There's some other questions. So one question is, can the load be imposed other than point loads, such as bending moments? So we can kind of answer those questions. I'm just trying to see if there's any other questions we can answer right now. And it does take into consideration. There's just a question whether it considers shrinkage and creep for the long-term deflections, and that is in the software currently, right?
Mm-hmm. Yeah. Sorry, I was looking at the detail, but yeah.
Okay. Let's go ahead and close that poll, and I'll just share the results. So, kind of as expected, there are a few honest people that just saying they're over designing the member, just kind of using some simple methods, but primarily using spreadsheets or strut and time method. So thanks for answering those. Let me go ahead and hide that, and if you want to get into that question as far as with the loadings, or just kind of how to input a moment, that type of thing.
Yeah. So yep. Let me just bring this example. When I select, when I was modifying the other example, I changed this to trim at none. But if you keep trim at one of the ends or end or beginning, the other side can be, let's say, like just trim, and then you will need to input those internal forces, let's say. So here you can see that you can input those. You don't really need to model the full, beam, but you can input this internal forces into that beam.
Okay.
All right.
Thank you. Yep. All right. I'll let you go.
All right. Yeah. So now let's jump into this example. I wanted to show this example because we also have the option to import the geometry of the model by DXF. All right. So that's how I am going to model this example. Probably you have this detail in CAD software, so you can use those drawings to import this type of geometry. That it's kind of complicated, not that much, but I believe it's easier if you can bring the drawing from it. So once you are here in detail, again, you click over the new icon, and then in this case I'll just use 5 PCI, okay, and for the DXF import, it's important that you select general shape, right? So once you select that, then you can see that here either you can bring new entities or import it from DXF. So I'll use this option and then select the DXF that I have already prepared, okay? Make sure you select the correct dimensions, okay? So I'll change that to inches, and then I'll select one of the edges of this drawing and then select consecutive button over here, and that will be my outline, okay? Once you confirm this is okay, then you just click OK here, okay? So now the shape is over there. Then you can change the thickness of that element, and then you can see the real 3D dimension. So look at this. All right, so you don't have to really worry about the geometry input. Then if you want to edit this shape over here, you just click over here, edit shape, and you can modify the coordinates of those points that you're seeing on the screen. All right, sorry. So it's really easy to make modifications of the geometry. We don't really need to follow the templates that we have over there. All right, so that's one thing. Then you will need to, for instance, in this case, again, place another line support. For instance, in this case, I can put that line support in H number 7 because I am seeing here the 7, okay? So that will be 7 there. And you can put it on the whole length. And you can input the support or even the stiffness, or the real stiffness of that support there. Okay, so let me just change it to model view so you can see here the support that was modeled there. Okay, and again, for instance, in this case, this problem, again, it has a vertical load or a point load coming from the column, right? So you can use this bearing plate at the top, okay, here on the H number 3, that will be 4,0, and then you move that X position to move it laterally here. Up, 2, 0. Okay, so now it's there. Okay, so I won't focus now on the loads. I have the model already prepared, but the thing that I also want to show you is how to add reinforcement from DXF as well. So every time you bring the reinforcement from DXF, those will be bring by groups of bars. All right, so I recommend, let me just show you how I model this. So I'll click again on the DXF where I have the reinforcement. So I model one, let's say, bar per group of bars that I want to create. So for instance, in this case, this is the vertical rebar that I want to put here. So this will be from here till this dimension, right? So that's why I'm just using one, because once I am in the main reinforcement area, I can put how many layers and how many group, or bars I want to put along that distance. So that is why I'm just putting one bar. Okay, so let me change this to inches, and then once you're there, you select the bars. Okay, so let me press Control, so I keep selected all the bars, and then I click over Select. Okay, so those are going to be the group of bars that will be there, so you can see it. You will see it over here. All right, so this is the first one, and I want 5 layers, and I want 2 bars in that layer. I'll change this to 10 inches. So let me show you the real 3D model here. Okay, so you can see 5 layers and 2 per layer. Okay, 2 bars per layer. So that's why I'm just modeling one line in my DXF. Okay, so let me just copy their details over here. So that will be 1 inch diameter. Okay. I'll keep the basic anchorage there, right? And then the second group will be this bar over here. Okay. And I'll have 5 there. Okay. And that will be 9 inches between them. Let me just put the correct dimensions over there. Now again, that will be 10 inches. Okay, 2 bars in each layer. And again, that will be 1 inch bar diameter, 1 inch diameter for those bars. All right, so in that case, you can, the advantage of using the DXF import option for reinforcement is that you can set up the overlapping distances or lengths over here, right? So let me bring the finished one, okay? So you can see the different groups that I modify from the DXF import. So you can see all the groups of bars that I model here. And the important thing is that I am going to upload this model into the webinar website so you can play around with this model if you want to play around with the trial, all right, and everything. So then after that, I just place another group of the horizontal reinforcement, and that is how it looks in the real 3D view. All right. Then in this case, this is the finished model. I also add load impulses in dead and live load. Okay, so you can see this the load over there in LC1 and LC2. So finally, I already run this analysis, and you can see the stress flow over here. And well, I didn't talk about it, but I add supports at these different heights. So that is, this needs to be like at this position. And that is representing the different levels of the building where you have a slab, all right? And I added that as point support, I believe. If I can go into geometry, sorry, distributed point support. So there are some differences between the supports. So and well, different types of details that you can add, right? Like this support type. So you can see the line support, bearing plate support, patch support. So there are different types of geometry that you can add. Also different load transfer devices. But one topic that we wanted to share with you is that we have this IDEA StatiCa campus, where you can learn everything about detail, and it's very useful because you go from like knowing nothing to basically finish a model by yourself. So let me just show you here in the screen how it looks when you start this campus. You will need to sign in, create an account, and you can start this training over here. So you can see the course navigation. Okay, so you start with some videos, some articles. For instance, if you go to geometry and supports, you can see the type of elements you can create, the supports and loads, transmitting components. And for instance, here you can see all the details about those supports. All right. So, well, that's it from me, David.
So there's a question about surface loads, and it's really not a surface load, it's more of a line load at this point, because we are looking at a planar element. So you're only loading the edges. You can't necessarily, in-plane loading is what it can handle currently. There's another question, just basically about in the future whether we'll be able to simulate soil interaction with a concrete base, kind of putting spring supports in. I think
we can put the spring if it's let me just select this line support. Yeah, flexible line support. Yeah, we can set up that.
Okay, so that's already there. So just kind of let everybody know, our next webinar is going to be on November 1st, and that's going to be back on the steel topic and looking at some complex modeling. That's one of the things that we get a lot of cases, questions about from our users as far as how to use some of the more complex operations and kind of in combination to modify and to model the connections that you're looking for. In addition, we will be at some live events in the next month and a half or so. We'll be at the Structural Engineers Association of Texas later this week, tomorrow and Friday. Also in October, we'll be going to the SDS2 User Summit with some interesting things to share there. And then in November, we'll be at Trimble Dimensions for our Tekla users, as well as the NCSEA Summit.